Hi there, how are we doing? What have I got for you today? Well, to start off with, I've got my cup of tea. Nice, strong. God damn, that's strong. 20 tea. Cup of tea. What have I actually got? Well, what it is a little circuit I'm going to try and create. I don't know if you can see that properly in there. And what this basically is going to do is I've got a mono input and a stereo output. Because see, what I've got is this microphone. Now, if I want to record something from my monitor, I can use the webcam, which ain't brilliant, and the audio on that is rubbish. Now, not to say that this is a particularly great microphone, but it's better than the webcam. It makes me sound like I'm in a box when I'm talking to the webcam. The only trouble is this has been designed with a mono jack, one of these large mono jacks, because you plug it into probably like an amplifier, like a guitar amplifier type thing. And I need it to be stereo because obviously my input into the computer is a 3.5 stereo connector, like this adapter, which can take this larger connector, make it into a 3.5 inch, 3.5 mil, sorry, connector. The only trouble is like I say, this is mono and this is a stereo. Now you might think, oh that's great, plug it in and I'll get stereo, but it doesn't, because the way that this connects means that I still only actually end up with the one channel being connected, because this length of this means internally in here it probably connects the earth and channel 1 down to earth, and I only get the single channel coming out. So this little circuit is basically to take the mono and turn it into a proper two channel stereo output, so that when it goes into the computer, the sound part of it picks up two channels and not just a mono. Well, I've got it made up on the breadboard, and I'm going to see how well that works, if it works at all. So let's go on and have a look at that. Okay, so what have we got here now? On here I've got, on the breadboard, I've got my circuit made up. I've not quite got all the right capacitors, so it's a bit hodgepodge where I've had to use several capacitors to get the capacitance I want on the output, which isn't brilliant, but let's see if it works, and then if it sort of works, then I can look at getting and buying the right value capacitors that I need. I've got my input here. This is coming from this box, which is actually just a 555, and I've put in a bank of capacitors and resistors and switches so I can change the output signal. So that does work. It seems to give me a nice, well, I say it gives me a nice output. It gives me an output that's sort of usable, because I don't have a function generator or signal generator because they're expensive. And then the next thing I've got is this little circuit, which is an LM386. Now it's a bit scratchy because obviously it's not in a box, so there's sort of interference and noise and that, and it's a bit scratchy, but it does work. Like I say, my main circuit I'm testing, and a speaker, just a speaker I had that I made a sort of bracket for. So let's turn some power on and see what I get out of it. I'm using 9 volts. It's 9 volts onto this. That's LM386, also 9 volts. That tends to work best from 9 volts. Can work quite well from 12 volts as well. But 9 volts today, and this is 9 volts as well. So everything's going to be 9 volts. Nice and simple. So first of all, turn it on and turn my input on. Now let's get some volume on that, and at the moment you can't hear anything because I've got no signal. So let's turn this. See, that is very, very scratchy. Let's turn that down a bit. See, so it's scratchy, yeah, very. But I am getting an output, so it's. What I'll do is turn that, turn it up. Just turn that volume down a bit. So I am getting an output out of it. It's giving me an output. So I'll turn this. So I get up to the higher frequencies. Notice there actually though that all I'm getting now is my static. Yeah, so I've got to keep my finger on this pot because, like I say, it's dead scratchy. It's not in a case, and I should try and sort that out, put it in a case and earthing this board properly. There I've got a signal. There it's just a scratchy static. A bit of signal in there, but not really, not till I come down to there properly, because hopefully this circuit is killing off anything that's really high. The low end is quite low, so pretty much all the signal will come through. Probably better with an audio signal into there, but obviously copyright, can't play your music, sorry. So this is the low end. See, still getting signal coming through. Still in there. Can't turn it up really because the thing gets a bit scratchy, so let's try and turn the volume up on that. Never mind. So yeah, the circuit does work. So let's have a look at that circuit diagram and find out supposedly what I'm doing with it. So here we go with the circuit diagram for this circuit I've put here, built up on the breadboard. Now basically very simple. This really is a simple circuit. We have a mono input, so the signal is going to can be split both off to two channels. Now first channel up here and the second channel here are basically exactly the same, and the reason they're there is just to give a bit of a boost to that signal. This is a Class A amplifier through this transistor. Biasing is exactly what you would do for a Class A amplifier. Basically very simple. Trying to think what I've actually put on there in this instance to bias it up. I can't remember really. I biased it up probably to get a couple of volts on here. This at the moment is an electrolytic, and I'm trying to think which way I put this electrolytic in, and I get the feeling I've put it in, oddly enough, with the positive on that side, because the input signal is higher than what my bias point is here. And then obviously a bit of biasing here to keep this signal up so that I can control the current to some extent. Resistor here, this sets how much it's going to come through. Got my output. Again, this has got the positive on this side. Again, I don't want that to be electrolytic. If I can find the right capacitance that's not electrolytic, I'll put that in there. might leave an electrolytic in here, and then here, this part is my filtering to basically try and control what I'm getting out on my stereo output. So that what I've done it for is, I think I've set this to be something like 50 Hertz up to 5 kilohertz, whereas this side, I think, what have I got? 1 kilohertz up to about 18 kilohertz. So that's dealing more with the lower side of stuff, and that's dealing with the higher side of stuff, but there is a big overlap. So you're not getting any sort of loss anywhere. So we're dealing with the full range, but this side is dealing with the lower part, and this side is dealing with the more main part of the signal. And that's all there is to it, really. I mean, these two, I've got basically two here, and I've got that and that. So I've got a low pass filter and then a high pass filter, and the same down here. You know, it's just an RC filter, if I can learn to write, an RC filter, 1 over, so sorry, frequency output equals 1 over 2 pi RC. So if we just change that around, so we want to know the capacitance. That's how I've learned to do it, is that you decide on what resistance you want on these. So I don't want to stop too much of the signal, because the signal's quite low, and even with the amplification it's still a very small signal. So really I've put in there 100 ohm resistor, and then because I don't want to lose too much of the signal to ground on the high pass, this is a, sorry, it's not 100k, it's just a 1k. Same here as well, so 100 ohms and a 1k. So then I got to determine, knowing what I want my ranges to be, what these capacitors are going to work out to. So like I say, to work out my capacitance, that equals 1 over 2 pi RF output, what I want that output frequency to be, and that's given me on my calculations this one here to be a 3 microfarad, this one to be a 318 nanofarad, this one here to be 159 nanofarad, and this one to be 88 nanofarad. Now obviously I'm not going to be able to get exact values, so I'll look around to see if I can find a capacitance that's as close as I can get to those values and put them in, because at the moment I've got several capacitors to try and get close to that capacitance, which isn't great. And I'll also want to change this electrolytic to be a standard capacitor, but I might leave the electrolytic in there, a 1 microfarad electrolytic in there, and of course, just like I say, just the biasing here on a Class A amplifier to make sure I get a nice signal coming in and a signal out, which it seems to do from my 9-volt supply. So that is what this diagram is, that this circuit is doing, and it seems to work. What I've got to be careful of, because I don't have a function generator to put a specific input in, and I don't have a oscilloscope to see the output, then I'm going to have to sit down and calculate what my output current, what's going to be driving through here, what voltage I'm likely to have, what current I'm likely to have coming on the output, so that when I plug it into my computer I don't fry it. Basically I don't destroy my sound input on there. But as you saw, because I've got to use this amplifier to get any sort of signal out. I do have to do that because I've tried it without this a little amplifier. I basically get no signal out. There's not enough to drive a speaker of any sort, so I don't get any output. So the signal is still very low, but not so low that when I plug it into into my computer, that the audio in the box should be able to actually deal with that and amplify it enough to give me an output. So then I should hopefully be able to use this microphone to do some voiceover on some tracks and stuff, some on the videos, without it sounding like I'm talking into a cardboard box. So next plan will be to get all the right parts, get it breadboarded up, and then test it again and see if it's starting to give me something sensible. So it looks like there's going to be a part 2. So there you go, a very simple circuit. Just taking a mono input from this microphone and getting a stereo output, so I can plug it straight into my computer, so I can do things like voiceover, or if I'm recording from screen without it sounding like I'm talking into a cardboard box, which would be much better than the sound quality I have been getting. A bit of work still to do, so it'll be a part 2. Got to get the right capacitors and build it up onto some board, be strip board of course, but hopefully I'll have that built up and then testing and see what we can get. So if you like this video, give us a thumbs up, subscribe, all comments are welcome, just put in the comments box below, and I'll catch you next time. First of all, time for another brew, I'm thirsty.